Thank you, everyone. Thank you for waiting quite a while for dinner, and also thank you for putting up with a bird taking out the power, actually. So, as Ryan introduced me, I'm Matt Moe. I'm an iOS engineer. I work here at Pinterest on our cross-functional team. We develop test tools here. So, just wanted to get a gauge of the makeup of this audience. I didn't expect there to be this many people, but I'm happy to see you guys. So, who works with tests? Raise your hands. Okay. Who actually directly works with test sharding and has heard of it? Okay, so I'm glad that this works out for the content of my presentation then. Okay, so the general overview is I'm going to briefly go over what test sharding is, why it's important, and what are some of the different ways to shard test, and also like how Pinterest does it. I'm going to share with you what we've learned along the way. All right, so okay, cool. So what is test sharding? Test sharding is intelligently dividing up your tests into groups. These groups are then run across multiple machines in parallel. So why test shard? Well, let's start with testing. There's a lot of people in here who run tests, and we know why we run tests. It's to preserve our sanity when we're developing code. When we test, we need the results quickly. We need the results back fast. So test sharding is important because it allows us to massively increase our work efficiency as software developers. And when tests run faster, we're able to iterate and fix our code faster. So how does it usually start? You usually start with a small suite of tests, maybe 10 to 30 minutes worth of it, and you keep on writing more and more tests, and that starts to grow. You're usually running them on your own personal machine. Eventually, but the problem is that the machine gets busy running tests. You're not going to be able to write code while you're running those tests, and so you're definitely going to want to be able to write tests. So what you do instead is you move it over to your CI. Now, sure, you're going to lose the privilege of sword fighting once you've moved it over to CI, but who wants to wait for the test to run and you want your computer back? So let's say you have hours of tests running on your CI. Those are all running sequentially. They're just running very simply. They're not running on a bunch of different machines yet. But who wants to wait an hour to know if their code is safe? And you want to know those results quickly. You want to get those results back quickly. So what do you do? The short answer is you run simple test sharding. You run them You run the tests parallel. You run them each one test on each machine. It's the simplest setup. It's the easiest one to get working. And as each machine becomes available, it takes on another test. So let's work through how this actually plays out as an example. So let's imagine you have 20 tests and you have 5 machines. You only have 10 tests, or you have half of your tests are take 40 seconds each. Half of those tests take 70 seconds each. Let's do a quick calculation of just how this would run on just one machine. So you have 10 tests, 40 seconds. That's 400 seconds. You have another 10 tests that are 70 seconds. That comes out to 1100 seconds, and 1100 seconds comes out to be a little bit over 18 minutes. So this is just for the simple example of you're only having one machine, you're running all those tests sequentially on that one single machine. When we actually shard, this diagram is to kind of demonstrate how it would look. So what I'm trying to show here is you have the 5 machines on the left, and the time basically goes from left to right. As each machine becomes available, it takes on a 40-second test, then another 40-second test, then a 70-second test, and finally another 70-second test. If you look at this, this is the best case scenario where the tests get distributed, at least time-wise balanced, across all 5 machines. And because we're testing in parallel, we care about which one takes the longest. Fortunately, in this case, all of them take around the same time. This is about as fast as it can go. So doing the math for that, it's 40 plus 40 plus 70 plus 70, comes out to 220 seconds. That's the time that it's going to take for your test suite to finish running. Now, what about the worst case scenario? Test machine number 2 gets 70-second test. Once it finishes, it gets another 70-second test, and then it ends up with 4 70-second tests, actually. Whereas test machine 4 only gets the 40-second test, and it actually could be a little bit more balanced. But because we're waiting on the longest task, what this comes out to is basically 280 seconds. So you have a range of around 220 to 280 seconds, basically from this kind of sharding. We'll be taking questions at the end. Sorry. So, actually, sorry. Do you have a question?
Wondering because your systems distribute the test evenly to the whole machine, all 5 tests. Are you able to whatever machine is available, start pick up a test and run? So this way, if one machine pick up 70 seconds, then probably only run three tests. Another machine pick up the 40 seconds, can run 5.
Yeah. So that's actually something that I'm going to talk about later on. I'll go over that and review that. So what I wanted to communicate is essentially that test sharding is much more than running your tests in parallel. The reason why is because, as you can see from these previous examples, this is how it may come out to. And actually, what you want to do is you want to dictate. The reason why we have test sharding is you want to dictate the order in which these tests run and how they're actually distributed across the 5 different machines. So earlier in this, we showed the best case scenario. We have an actual best case scenario that we can emulate. And if we can actually distribute the tests into the right buckets, then we'll have the best shards. Then we'll actually end up with this. So just to do a kind of quick comparison, when you're running tests in a sequence, it takes 18 minutes, 1100 seconds. When you're running one test per shard, you already get a massive gain of going down to 200, a worst case scenario of 280 seconds, or a best case scenario of 220 seconds. So that goes from 18 minutes to roughly 4 minutes. It's already about a 4 to 5 times improvement. And then in the final scenario, where you actually shard it by time and you control how the tests are actually bucketed, then you end up with the best case scenario of 220 seconds. And you guarantee that because if they're always running in this form, they're going to be always balanced and they're not going to be running in the worst case scenario. So what I want you to take away from this is test sharding is really important. Naive sharding is a massive win. I mean, if you're just running things in parallel, that's already better than running sequentially. But in order to further optimize sharding, you need to distribute the work. You need to actually dictate how it's going to be distributed. And the reason why is because your automation test tools, whether you're using Jenkins or BuildKite or something else, they're going to be agnostic of the test times. They don't know what your test times are. They're not going to know how to actually balance it out. So it's part of test sharding to actually dictate that. So we've gone over kind of just a brief example of what test sharding is. Now we're actually going to go over how we do it at Pinterest. So at Pinterest, whenever we're optimizing our tests, we're optimizing for 3 different metrics. We're checking for whether or not the tests, how fast they run, how much the tests actually cost to run the entire suite, and how reliably they actually they pass. This is just a general overview of how our test stack is. And these are actually the steps that run on our automation tools. So you check out the repo, you compile the app, and this orange step is actually the most important part. You generate test shards from your test time history. Then after you've generated the test shards, those test shards go to the machines. Once the machines have finished running, then the machines actually send them up to a database that aggregates the test results. So this is the general abstract, but for our Android test suite, we rely on a framework called Flank that works with Firebase test labs. So the machine part is actually on Firebase, and the orange step is handled by Flank. For iOS, however, what we actually have is in-house machines, our own Mac farm, where we run the tests. And then for the orange step, in order to get our test history time, we actually rely on our in-house framework called Metro, and that's where we store our test results. So I'm going to go over an example of running tests and how we figured out how to optimize it for Android. So I have a question for you guys. Who has infrastructure here where you're running your tests and you're being charged by the hour? And by being charged by the hour, I mean you're running it on something like Sauce Labs, or you're running it on Firebase, some kind of a third party. Third party. Yeah. Okay, so we have a couple people. So whenever you're running it on an outside infrastructure, you're going to be charged for that time. And as I mentioned earlier, our Android test suite runs on Flank and also on Firebase Test Lab. We're not being charged for Flank, but we are being charged for Firebase. And the thing is, Firebase charges by the hour, but it also rounds up to the nearest minute. So going back to the example at the beginning, if we only have one test per shard, and it ran, so we have 40-second tests and 70-second tests. What these actually come out to, So this would be the naive sharding, where it's one test per shard. This would be some more intelligent sharding, where we actually group them by test time. If you do the actual math, what would end up happening is, because we're actually rounding up to the nearest minute, we have 40-second tests and 70-second tests. So those end up being rounded up to respectively 1 minute and 2 minutes. So if you're doing one test per shard, what you'll end up with is a cost of 30 minutes. Versus if you're actually balancing your time sharding and you're sharding your test by how much time they actually take, you end up with a 4 minutes per shard, and that comes out to about a 20-minute cost for the entire suite. That's already a 33% decrease in costs. So now actually going to Pinterest, what we did. So we ran our test suites with different configurations. We ran our test suites with one test per shard. We ran our test suite with 2 minutes balancing in terms of buckets of 2 minutes, balancing in buckets of 3, 4 minutes. And the hypothesis was essentially, okay, Firebase has more simulators probably than our tests. We think that one test per shard will be the fastest still. However, for each configuration, 2 minutes, 3 minutes, 4 minutes bucketing, it should get gradually a little bit slower. And the other idea is also that the cost would essentially decrease as we bucketed more tests per shard. So this is the actual test data of what happened. So we took the base test data for just doing one test per shard, and I want you to see the cost, which is $3.80, and the time being 9 minutes and 23 seconds. So when we move to the 2 minutes test shard, you see this gigantic drop from the $3.80 all the way down to $2.57. However, after that, the drop is only minimal. It's only about 10 cents, relatively speaking. So going from that data, we decided basically that 2 minutes per shard is optimal, at least for the biggest wins. And because we still wanted to be able to run them pretty quickly, we went with that. So that was a 29 to 32% reduction in costs, 6% faster test times. That was actually the surprising part, which is essentially that we expected when we moved from one test per shard to 2 minutes per shard, that would actually slow things down. And the reason why is because the earlier example I gave is actually primarily, it happens when you have less machines than you actually have tests. When you can't afford to just run one test per actual machine. So what we actually later found out when we investigated was that the reason why it was faster with 2 minutes of test shard was because we actually had more tests that were waiting for simulators to spin up. So Firebase didn't actually have that many simulators, and they didn't actually have an infinite number of machines. that actually ended up adding the extra time, and that accounts for the time increase, not the time increase, the time decrease, the increase in speed that we received for our test times. So that was just going over how our investigation for Android and how we decided on how many minutes per test shard we would go and what kind of configuration we would go to. I'm going to show you also a little bit of a different case for iOS. So for iOS, we have our own internal infrastructure. We have our own Mac hardware. The difference between this and the Firebase case is Firebase we were paying for Google's, but internally we've already paid upfront the cost for actually purchasing all the Mac hardware. So we're not actually being charged money based on how much time we take, how much time our tests take. What we care more about at the end of the day is just how much we can optimize the utilization for the Mac hardware. So we wanted to boost our utilization, and we wanted to, by doing that, we essentially wanted to increase the number of simulators that we ran per machine. So I don't know about how many of you guys are part of iOS or work with iOS tests, but iOS simulators are notoriously expensive on the processor, and I think when we talked with Firebase, it was only like maybe 4 simulators per Mac Mini. But regardless, what we wanted to compare was essentially runs with 5, 10, 11, 12, and 15 simulators. Just a tidbit. So what we run in-house is actually, in order to actually run the simulators in parallel, we run with Blue Pill. It's developed by LinkedIn and maintained by them. So for our hypothesis, we expected a kind of curve up optimization. We expected that on the left side, on the small end, with just one simulator, it was not that. Sorry, this is a graph of speed, not necessarily time. But we would expect that it would take a lot slower. And then we expected that we would be able to get more test results per test run, if we were per test machine actually. And we were expecting that, when we go from 5 to 10 to 11, we would kind of find a sweet spot at the top where this would be the best number of simulators to run. So this is the test data, what we ended up finding for our test suites. I'm not including one test per shard because that's obviously going to take a lot longer. But keep in mind that these tests are basically right now what we're doing is we're sharding based on the actual number of tests per shard. And that's number of tests that are running in parallel per machine. So as you take a look at this test data, what you notice is on the far right, the corner of the chart, what we have is essentially the total number of times any test in our suite actually retried. That's an indicator of flakiness of the test, how many times it failed for whatever reason. And what we found was that starts slowly creeping up after 10 tests and 10 simulators essentially per shard. The reason why is probably due to the actual sharing the machine's processor and sharing the machine's resources. So when we were able to run more simulators per shard, we got more tests done, and actually for relatively same speed. So that was really great. In the end, what we elected to choose was 10 simulators per shard, and the reason why is because we weren't expecting to see an actual increase in the flakiness of our tests. What happened was we found that once you went to 11 tests per shard, 12 tests per shard, 15 simulators per shard per machine, it starts to skyrocket, and there's a lot more instability as a result of that. That is something we're optimizing on, but this was just an initial test just to get the actual architecture to work. That's why. So I can also answer a lot of these in the later QA. If you have any questions in regards to this actual configuration, please talk to me afterwards. All right. But yeah, so that was just to conclude how we actually figured out how many how we wanted to shard our tests for Android and for iOS. How you end up sharding your tests really depends on what your team's needs are. I mean, do you have videos of your tests? Because if you have a video configuration, that might require extra time. Do you need to handle flakiness? Do you want to have a solid green as a test result? Do you want to test across multiple devices, OS versions? And do you have different kinds of tests? Do you have unit tests, which might be less flaky than integration tests? Do you have performance tests? It really depends on what your team's needs are. So I'll be available at the end of the presentations to take questions. Let me know. Thank you.